welcome everyone. I guess it's time we can start the session. Thanks a lot for your interest in this. Because we organize as a kind of ad hoc. John and me, and also I see Ruth is online. The couple of us, we made the decisions like in the last minutes. Say, okay, we find an empty spot on Thursday. Seems one room is still empty. Let's make a session for the semantic web technologies, and we'll make it. And also thanks a lot to the other speakers. Adam Shepard, actually, he cannot be here, but he's very active. He provided us a PPT slides and also a recorded video. So, but before we start, first you can go to Sketch. You can go to the website, find the entry of this session, and you can find a shared Google Doc. On that doc, I made links to all the shared resources, including the PPT slides and also the video shared by Adam Shepard about schema.org. And I also shared a link to the YouTube playlist of, I think it's about 8 or 10 recorded videos from the past year. There are a number of really interesting topics. So if you want to keep a record of those resources, the best way is go to the shared Google Doc. And also, may I ask you to write down your name and your affiliation in the shared Google Doc. So later, if we want to contact you, just like to share more resources about semantic web, either data sets, technologies, or future webinars, we're able to reach out and find you. Okay. So first, let me ask you, anyone does not know ESIP has a semantic web technology committee? Okay, I guess everyone knows it. That's good. Okay, let me just go ahead. So here's a brief agenda about this, and because it's kind of ad hoc. So let me first give a quick overview about the Semantic Tech Committee and also the activities we have organized recently. And then second, Adam Shepard, he shared a video about science on schema.org. So we can just play it. And people online, if you cannot hear the voice, you probably can just click the link in the shared Google Doc, and you should be able to find the video. And then John will share some more updates about the community ontology repository. I think he already showed you some details yesterday. There was a session, and then he has more sources about like the details in semantic web evaluations for choosing terms, and also I think he's preparing a white paper on that. So probably he wants to invite your contribution. And then also another announcement. Oh, okay, Brandon just entered the room. Brandon will have another session about semantic web technologies tomorrow morning. So if we cannot finish, because I believe we're going to have a lot of time for discussing and brainstorming, as I can saw yesterday's in Tyler's GCMD session, there are so many interesting discussions. So today, if we cannot finish the discussion, or we just feel we still want to continue the discussing, please come by tomorrow morning to Brandon's session. We can still continue the discussion and the brainstorm, because this is still a very active research field. Long time ago, we talked about vocabulary, and then we talk about ontology, we talk about knowledge graphs, and now we also have the large language models. So there are a lot of interesting topics we can discuss. So let me quickly go through this and I listed on the slides, and those are my part. Since the summer of last year, I took the role of the chair for the Semantic Web Technology Committee from Brandon. Brandon served the committee for 2 years. So in the past year, I was trying to coordinate some invited talks for our monthly webinars for the committee. So I was trying to Because in my experience, many people were asking, like, what exactly can semantic technology do for my work? So I was trying, so to answer the question, so I try to invite talks from people in different disciplines, and also the highlights of the utility or the real world application of semantics or semantic technology on different parts of data intensive science, including service and also reference and reasoning, and also data rescue. And also Brandon and John, they were still very active, even they did not take like the leadership or as the chair of this committee. So Brandon was still leading the work on refining the suite ontology. I believe he was also doing a lot of other work related to ontologies and semantic web for sure. And John was leading the community ontology repository and also some other community service works. So I believe he will also give more details about that. Okay. And besides this semantic tech committee, within ESIP, there are also several other small groups, and many of them they're like spin off from this committee. It's like derived working groups because they have more focused topics. So they said maybe it's better to set up a separate group. Probably this is not a complete list, but when I look through the ESIP website, I can find semantic harmonization cluster, the science on schema.org cluster led by Adam and Doc. And also we have soil ontology and informatics cluster, I think it's led by Cassie. I believe there are more works related to semantic web and semantic technologies, but here's just an incomplete list. I just want to show semantic tag is still very active within ESIP. Also, sometimes people don't call it semantic web or semantics. So here I want to quickly show you, because I think some of you may have not attended all of those webinars in the past year. So let me quickly go through just using those fancy flyers created by Alison. And I want to show you what are those topics we have covered through the invited talks in the past year. I think the first one was in October last year. It's from my own postdoc, Dr. Jewang. Now he's in UCSB. What is that place? Is National Center for, in fact, NCEAS. Did I spell it correctly? At UCSB. Yeah. And actually the involvement within ESIP activities is like a catalyst for her to find a job at the UCSB. That's really good. But her talk is about the so-called semantic segmentation. I think this is a very popular technique of nowadays in remote sensing image processing. It's remote sensing images. Yeah. And the second one is from Wen and her PhD student Yuan Yuantian. They talk about the nowhere knowledge graph. I think this is an NSF funded project. Wen is a co-PI and also Christoph Janowski at UCSB. Now he's in University of Vienna. They have a website, and Wen talk about the structure of the knowledge graph because it's really huge, and they spend most of the time on the application. And the third one was from Craig Lovelock. He's from University of Southern California. His work is really interesting because it also addresses like a topic of national importance is critical minerals. And in his work, I think this is a DARPA funded project, but also with support from USGS and a few other resources. In their work, they use a lot of interesting techniques to do the legacy data rescue from a lot of maps from USGS and other resources. But then another highlight is they use the geospatial ontology to represent the rescue data set, and they use a lot of interesting reasoning and inference techniques enabled by geospatial in their work. And then the next one is more related to solid earth science. Is from Professor James Ock from Purdue University. He and his colleagues built I would call it like a controlled vocabulary, but it's huge related to lithostratigraphy, because this is the most heterogeneous terminology. I think the most, or maybe one of the most heterogeneous terminology in the field of earth science, lithostratigraphy. But he did a really nice job because he's an expert in that research field, stratigraphy. The website is called geonex.org. If you have internet now, you probably can even go there and have a look. It's geolex.org. And in March of this year, we have Sarah Maxson from the LINQ markup language community. This is a linked open data markup language. And since it's a very popular language now for allocate your data sets, and especially people in the field of biology and bioinformatics, they're using this to increase the interoperability of the data set. And Sarah also mentioned the potential of use LINQ-ML for earth and environmental science. I think there are already a few use cases in the field of environmental science, but for earth science and planetary science, at that time when I was doing Google search, I did not find much use cases, but absolutely we can see the potential. And after that, we have Boyan. Boyan absolutely is a pioneer in the field of geoscience, ontology, and knowledge graph. And he talked about, I can even mention a little bit personal history. When I first began my PhD study, and that was a really long time ago, 2007. Actually, I spent a whole week at Geological Survey of Canada in Ottawa. And he gave me a lot of guidance and also showed me what can be the potential direction for ontology and semantic web at that time. And he showed us, I think it's also related to data rescue, but the background is similar to the work of Craig. It's on critical minerals. And he showed how to use semantic web to organize the rescue data set, including metadata, identify surface, and also the interlinkage. And I think between him and Steve Richard and a few other people, they're also working on a general ontology called geoscience ontology, including those for minerals and rocks. And he also tried to use the geoscience ontology in this part of work. Yeah, and then in May, I think this was the very last one we organized before the July meeting of this year. Is from Dr. Lucas Shanneman from my university, University of Idaho. But he did a really nice job. And also in the past 2 days, I actually I can see how popular the topic is now, and it's using large language model for clean the records in the open data service, and then use semantic embedding to improve the privacy, or not privacy, to include the quality or the quality of matching in semantic search. So his work is a part of an NSF project we're working on now at University of Idaho. It's called tickbase.org. It's for vagabond disease, but open data is a big part of the project. So we collect open data records from a number of resources, and also publication records from a lot of resources. And then large language models was used to help us to scale down the level of records. Recently, we have, I think, almost more than 200 million records. But finally, by a lot of interactive steps using large language models, we narrow down the scores to about 400,000. And then after that, we use semantic inverting to build up the front-end service. The database is still online and it's open. If you have an interest, you can go there and take a try. It's data.tickbase, Tickbase, data.tickbase.org. I mentioned a number of those resources. So if you're interested, you can go to the Semantic Tag YouTube playlist. All those talks I mentioned in the past couple of minutes, they're recorded and shared online. If you're interested, you can scan this QR code, or you can just go to the shared doc, find my slides. You can just click the link and you can find it. And then another way is you can just go to YouTube, search eSIP. There's a playlist. I think there's a tab for all the playlists within the eSIP channel. You just find Semantic Technology Committee. You should be able to find this one. And I can even find a talk given by myself. That was when I was still, I think this, yeah, was about 4 or 5 years ago when Luis was the chair for this committee. I talked about my work about how to use the interesting structure to track the version of ontologies. So that's my plan. I think for the, I just agreed to be the candidate for the chair for the next year. So if I'm selected, I probably will do a few jobs. First is I want to continue this invited talks and expand the topic on several levels. First is the discipline coverage. I probably can invite people from even more disciplines. And second is the technical level. So different parts of the semantic technologies, especially those on large language models, semantic inverting, and also those, especially those successful applications of semantic technologies. So that's my plan. Next, I think, you put this. Okay. Yeah, okay, yeah.
I wasn't sure where to put the name of the sequence.
Yeah. Yeah. Yeah, maybe you can start.
Sure.
Yeah, you want to talk with Brandon?
Yeah.
Okay. Yeah. Yeah, and then we can move on to Adam's video.
Okay.
Yeah. Okay.
Okay. Now yeah, I've talked enough today. What's it called? So for Suite, I don't know. I'll give you the Reader's Digest version, right? So I think I mentioned it in the talk earlier today where it was after Rob passed away, it sat for a bit, and then there was an effort to uplift it and open source it and put a decent license on it. So it's now in a GitHub repo, and there's been a lot of work on the ontology to make it sort of up to scratch, right? So like dereferenceable URIs, changes in scheme, and changing it's not cosmetic, but it's things that you need to do, but it's like at the file level, right? Like making sure all the headers have the same import statements and all that kind of stuff. It was sort of like a big cleanup. So we did that bit, and now it's about content. We're trying to increase the number of definitions. One of the ways that we're doing that is mapping to other vocabularies so that we can try, and like GCMD, one of them, looking at the other vocabularies around, trying to pull in things from, create mappings to other vocabularies like Wikidata, DBpedia, anything in the earth and Earth and Space Sciences we'd be interested in, but basically trying to develop a path where we can narrow down or restrict what the concept means and then figure out what the hierarchy should be or where it should be placed. Because right now, there are questions in many areas. Yeah, what's up, Beth?
One of the complaints about GC, she's getting fewer, you have to pick a path. You have to pick a path and get to the term through that pathway. And so sea ice was an example of one that shows up in two different
Yeah,
paths. And I think that happens in Sweet, at least the last time I looked at Sweet, which admittedly was a really long time ago. That was like, it had this concept of a realm and I, that was baffling
Yeah.
to me and
Yep.
and that you had to sort of choose a realm and if you chose badly, you were not ever going to get there. And are you fixing that? Are you cleaning that up?
that's, yeah, that's, so the short answer is yes, but it's not a straightforward process, right? So. Well, so one of the proposals was.
Yeah.
Well,
Yeah,
actually,
why?
so two things, right? One of the issues was Sweet was created before SCOS was around, right? And what you just described are, in my view, could easily be described as collections, if you wanted to try and bend them that way, okay?
Collections.
It could be a collection, yeah,
Collections of what?
just of terms that are related, like you talk about, like they're in the same realm, right? So it's a collection, but you can be a participant in more than one collection. It's just a way to group, like if you're trying to query a specific subset, right? Anyway. But yeah, I agree that the way they're set up now, it's not terribly intuitive unless you kind of have the experience and you've been following along or read through the previous documents. So yes, like I said, the short version is, yeah, we're trying to figure out what it should look like. And one of the previous proposals, I'm not sure if we're gonna do this, one of the previous proposals was to rip off all the relationships except for property relationships and start with just a massive bag of terms that are still useful without any hierarchy information, and then start from scratch and try and build it from either queries or anyway, yeah. Not sure, but it's an active area of discussion. So sorry that doesn't maybe help, but yeah, I know what you mean, and yeah.
And I think you asked why, not just start over, and maybe that kind of start over is what you meant by start over. Yeah, okay. Yeah, it is a little bit. Right. But also there has been a lot of work over the last 5 years, I'd say, in normalizing a lot of the discrepancies that were there before, fixing whole swaths where it was out of date when we had a more current, and I say it's all the other people, Ruth and Brandon and others, when there was a more current set of terms that could be used, replacing what was there with a more current set of terms. And it's, as it's deployed, it's a bit of an exemplar that we can point to as this is a way that you can have a semantic artifact that can be used in a lot of different ways, deployed in a lot of different ways, have the terms be automatically resolved. Basically, a lot of good practices are represented by Suite as it stands. So it's a resource, and as I think was mentioned in one of those videos, a resource that gets used by some people for analysis of different sorts.
Yeah, and one of the other bits of conversation that's come up is so I don't know if you went to the course session or not, but there are structures being created all the time, right? For research purposes or whatever. And like Marcia, your group, right? You may create something maybe temporary, or you may create something that's meant to be more persistent. And one of the discussions that we've been having is, what if Suite stayed that bag of terms that didn't have any structure, and it became a place where the things that were, but it was still like a production level, right, system, but then it was a place where the other structures that were perhaps at a more research phase we could bind them to, right? And sort of, so instead of having a project or something that you create that gets chucked on GitHub and then there's no maintenance, right? Because it's a research project, but having some way to sort of transition from research project to something that can persist. Yes, go ahead, please.
So if the issue is that there's this suite ontology and it's not quite what everybody needs it to be, there are things that that sounds weird, but there are tools out there for like transforming ontologies into like subsets or lenses. So there's a Go Slim and an NCBI Taxon Slim that you can make like a smaller version of these massive ontologies, or you can have, the relation ontology has the eco cluster and this cluster, and there are tools like Robot and Oak that will help you to do that somewhat quickly and easily. But as long as you're using the same queries, it's fine. So I don't know if that's the issue here, like that people don't want to use, or one of the many issues that people don't want to use. They think that if they need a little bit of Suite, they think they have to take all of Suite. And so they don't want to do it because they think it's too hard. But there's a solution for that.
That's helpful. I think, speaking for kind of what I think we want to do at ESDAS at NASA we're starting a project, to create metadata for individual data sets or variables, right? Instead of the traditional approach we've taken, which is to provide metadata for these big collections that have, sometimes 100 data sets in them. We want to now start labeling those individual ones. And to do that, we need vocabulary words, right? We need the right vocabulary, and we need to try to control the values that people put in. Otherwise, we're just going to have a big old mess, and it's not going to be very helpful. And so I think Suite might be the right place for us to look, but I just find it so cumbersome, and so, yeah, to me, I'm like, yeah, give us a bag of words and let us get views on it, maybe, according to our metadata elements. So the possible values for the measurement object or the measurement quantity, the measured quantity or the context or something, the possible values for those we'd like to have those in buckets that we can then provide, some access for the metadata curator to just narrow it down to those. And I really would not want them to have to start at the top of Suite and choose a realm and, all these things and try to make their way to the right vocabulary term. But I think possibly, the right kinds of terms are in there because it was a NASA funded project. So,
Yeah.
I'd be great. Find a way to.
So I think John should probably go soon, but I was thinking some of what you're talking about, at least in my experience. So when I was working on like an open source, we were building an open source science data portal, and we were trying to jam together a whole bunch of different vocabularies, because the idea was you can tag it up. We wanted you to tag it up, but we didn't care which vocabulary it was. We just wanted to know which one it was. And there was like 140,000 terms in there, right? But you didn't search for the terms. You just started typing, and then it was smart, and it just showed up, right? If it knew about the term, it would show up, and then you get to pick which one, which is different than I need to go find the thing I need, right? Now, I can appreciate what you're saying. I'm trying to figure out, like, I think there's more than one way to attach, right? The other thing, oh crap, I lost my train of thought.
I'll just fill in right there. Just by pointing out that this is a community activity and a community process to work on Suite. And really, if people have a need that they know how to address, it's perfectly acceptable to contact. Is there a contact? Go on the Suite Ontology channel and or contact Brandon and say, I'd like to make this, submit a pull request for this. Yeah, we're not gonna, if it's useful and constructive, the Suite folks are going to take that into account. Be happy.
And this is Ruth. I'm online. I raised my hand.
I-
But I just wanted to say, you don't have to start anywhere with Suite. You just go to like the bio portal, which has Suite in it, and you put in a term like sea ice, and the related terms come up. And you can select the one you want because you can see the definitions if there are any. And so I would never ever look at suite on GitHub for any reason whatsoever. I would like go to BioPortal or someplace that has that and search for terms that way. Core can do the exact same thing. I would never like look at a realm because
Yeah.
that word doesn't mean anything to me.
Have you done work mapping synonyms though? Because I do think
Yes.
that, you know,
In fact, we have a paper on this whole subject called semantic harmonization, where we did that for the cryosphere in Suite and Envo with all of the terms for the G3W.
what I'm wondering about is this, if I typed in, you know, irradiance, would I get radiative flux? Or if I typed in, you know, AOD, would I get AOT? Or, you know, the kinds of things that, I mean, maybe I would in that example, but we've got, you know, metadata curators who aren't necessarily science experts that are going to have to be labeling or at least working with the scientists and people that use different terminology. And I'm even a little worried about the situation where terms are over specified maybe, or you know,
I wouldn't worry about that with Suite.
okay.
I mean, Suite
Yeah.
doesn't go down nearly as far as Envo does into terminology.
Yeah, but so here, let me tell you again what I hate about Envo. Those concepts in there are enormously complex, and we need simple concepts, right? What did you measure? Aerosols, right? I mean, it might be something like that, not like, I don't know, some of those concepts in Envo are really insane. Yeah, I don't know that. Yeah, it could be. Yeah. Right. No, I agree. I just have sometimes found that the simple thing I'm looking for isn't there, right? That it sort of you know, I don't know.
So, so
It's just not general problems with ontologies. It's that sometimes ontologies are developed with a specific user group in mind, and then the next user group comes along and says, yeah, I have concepts sort of like that, but they're different enough that I really can't use that term. And that's, I'm wondering if, you know, that is something we would run into with Suite, and I don't know, you know, if it's
Yeah, it meets a certain use case. It won't meet many other use cases. Yeah.
when I have to create our ontology of earth science concepts, right? So definitely, I am not trying to just shoot down the use of ontologies here. I'm just saying that one thing that happens is that ontologies end up not being as reusable as you think they're going to be because they're specifically designed for specific
So
purposes.
I've three, John, you're up next. I have
No.
three things that I just want to mention, all right? One of the things that I wanted to, that I want to look at is, so Suite was made before a whole bunch of other stuff, right? So there's a shed load of custom properties that we don't need anymore because now they're in like GeoSparkle or some other vocabulary, right? So that's what I was talking about before, that about being part of the update process, and like removing the properties that we don't need or a duplicate because a standard has now been created. And and in that same line, there's also a whole 2 files on geologic time. And since then, Simon, Cox, and Nick have made, with the stratigraphy folks, they've made a geologic time ontology in RDF. So we don't need it anymore. We can just import theirs, right? So things like, real practical things like that about reusing the thing that was developed by the experts, right? Which means deprecating properties and deprecating classes, or binding the Suite class to the other one, whatever, get the idea. And the other thing was, Marshall mentioned, Boyan is building a geoscience ontology. That's, if I understand correctly anyway, that is his attempt. Him and Steve are trying to make GeoSciML into like basically ontologizing GeoSciML, right? Going from a data transfer layer to something that's logically coherent. And that was the impetus behind the comment before about taking research artifacts and trying to make them production level. Because when he's done, what's going to happen to it, right? So if it's just something that you make that then sits there, I don't know, because it might be used by the OGC. I don't really know, but that's the point. If you're making something that is meant to be comprehensive, right, and cover off a domain, then we should make use, we should be able to make use of the work. And I'm not saying that needs to go into Suite or whatever. This is kind of separate of Suite, but we need to figure out a way of taking those research artifacts or artifacts that aren't necessarily planned to be maintained. And how do you, where's the spot to put them? Where's the, are we gonna put them in core? What are we gonna do? So that's part of it's a hybrid. You're up.
I'm going to try reloading this presentation to get the very latest slides. Sure, might have done it. We'll see. So first thing, yeah, while I talk about core, you could maybe, yeah, I just won't pull any different things. Sure, got that. So who wants to-
Oh, I see the problem.
Oh, yeah.
I think you're good, thanks. So the community ontology repository, does anybody not know what that is? Anybody need me to talk about that? I think we all know, right? So we had the nice training session, and that went well. There are a lot of developments, many of them coming up in that session that I just wanted to go through fairly quickly. So in addition to training session, we've had quite a few ontologies, quite a few in core world is like 4 loaded within the last month or so, partly in preparation for this meeting and partly in support by GCMD, for example, which that conversation started 18 years ago with GCMD to see if we could upload their ontology. And bless Tyler, he uploaded it when we had the training session. And I could not be happier about that. They have, it was the science keywords that he brought in. There are obviously a lot of others, and we'll be talking about bringing all those in as well. And that's an exemplar ontology, I would say. There are a lot of them that are around that we would like to bring in, but that's one of the ones that will be really nice to have for mapping and other purposes. So also had discussion with the Grand Unified website folks at NASA who are expressing an interest in uploading their, sorry, I'm not making it hard. In uploading their standard ontology that they're using across all the websites. And so that's being explored as well, which is fun. Lets us move forward. Apparently, it's not always the case that GCMD can update their science keywords quickly. And the web people are having, thanks so much, appreciate that. The web people are having a lot more effort in making sure they can have current ontologies. And so it'll be good if we were collaborating with them. No, I need to just make it forward. Yay. There were tchotchkes. There are still tchotchkes. If you think you would like a t-shirt, this is possible. Then one of the things to emphasize is that the reason for core is to capture semantic knowledge that is happening as the result of ESIP. People in projects, people in ESIP lab, people in Funding Fridays. All of these things are producing semantic entities, and I'd like to start capturing them routinely, that everybody realizes that's where it goes at the end of your project or in the middle of your project. Brendan fixed some of the help links that were broken in the help, and that's quite a big improvement. We spent a lot of time advocating for and strategizing for the future. So I just wanted to, we did a lot of the filling out of surveys near the end of the meeting. I just wanted to point out the left-hand side, you see why people came, mostly to want to learn about core. As you can see on the right side, the experience level is pretty low. 1 is no experience. 4 is a lot of experience. And the vast majority are advanced beginners, one would say, or intermediate. And then there are other specific use cases that pop up in that. So that was 20 responses we got, and quite a number of different things that people want to do with the repository, which was exciting. Oops, sorry. I wonder if I could go back. Ooh, yay. Yes, I could, sorry. Then we asked the question, we asked them to prioritize the different things about core that they would like changed, because we really have the open question of, are we going to keep maintaining this? Because it does take work, and we're going to have to get funding if we're going to keep maintaining it. And really, we're going to have to find some way in which ESIP can say, yes, we are eager to have you, as opposed to, gee, we really wish you would go away because there's no way we can fund you. I'm being a little blunt there, but it captures the gist. So we're encouraging the people who work for different agencies to speak to their agencies about trying to make sure funding for something like this is provided in their funds for ESIP. And so that's a focus. I think it's the right, I think ESIP is the right place for this, and I think it's the right approach. And I think all of the agencies should be owning up to the fact that it adds value for them. But just because I think it doesn't make it so, and if everybody's going to turn away from it, I don't want to be one person standing all by myself saying, no, it's going, because I don't, I won't be able to do that indefinitely. And so this was a little bit exciting to me, because we got 13 responses that actually went to the trouble of ranking the different things that they really wanted to see. And we had a scheme where they could indicate whether something was so important that we had to do it or they wouldn't use core. And there were very few things that are in that category. The evaluation criteria for ranking this is a little suspect, because there are different ways you could do it, but roughly speaking, having solid documentation, fixing all the little things that don't work, and having high availability is pretty important to people. From there, it goes on down. That was interesting to me. So it may also reflect the fact that we were hearing about little things that don't work during the meeting, and so people voted more for that. Who knows? It's data.
Right.
No, most of those are feature improvements. And so the little things that don't work are things like Brandon during the demo found a few ways that you could make the system misbehave in one sense or another. There are a lot of edge cases that aren't handled or aren't handled well, and it's easy to find them really if you spend a lot of time with the system. So that's the end of that topic. They might have any other questions about that or comments. The other topic that I want to highlight, I've talked about this at every meeting I've been at for about 5 years, which isn't many given COVID, but we've been, I've been working for 3 or 4 years, more or less on my own, at starting to put together a bit of outline of how do you choose ontology terms? How do you choose ontologies? What are the metrics? What are the methods? And just starting almost a year ago today, all of a sudden, when I made it, people started saying, I want to work on that. So we actually have done 2 posters. This is the one that many of you might have seen at ESIP. That is the shows the outline of our work in progress, and the fact it's 19 pages gives you an indication that it's well started. And in this case, this was focusing on choosing terms. Asaya, and if you want to go to the document directly, you can get it with the QR code there. I was eager for that. And then Azia Lin presented a poster that we did a few weeks ago and presented at ICFO that was about choosing ontologies. And here we're emphasizing the fact that the current method that everybody uses is all over the current method that everybody uses is all over the map. But there's actually probably more fundamental mechanism, structured approach that you can use that is simpler to understand. The key point of a lot of this is that people would tend to ask me, so how do I choose? What's the method? What's the single evaluation criteria that I use to decide what's the best term? And, or what's the best ontology? And I knew the answer was something like all of these. But just saying all of these just wasn't satisfying to me. And so that's what started this whole thing going. And it's progressing at a reasonable pace. We meet every 2 weeks. It gets more and more filled out as we prepare posters and so forth. So if you actually have a question about how to choose terms, there's starting to be some raw data that answers the question. It's not rigorous at all yet. It's coming out of our model. I think I showed that in, yes,
Do
you
you
can see
mind, just because I
the mental model.
can't see what is in there. I'm
Yep.
really curious as to what your structured approach is recommending.
The structured rubric.
Yeah,
Yes. So the structured rubric starts with a bunch of relevance criteria, which basically is, indicate, we'll use it for terms. Does this term that you found, this is assuming you found 5 terms that might be a good fit. Does the term actually mean what you want it to mean? Is it something that the community has already, that you're dealing with, has already said yes to? Those are the relevance criteria. Then if it meets the relevance criteria, which many of them won't, then you can say, okay, how do I make a more refined choice about which one is best? And there the criteria are divided up into how popular and used is the term or ontology, how well is it following best practices, and what kind of governance and internationalization processes are there or are represented in the ontology or term. And so those are the major categories. It's divided into subcategories. You're welcome to, we can get you the documents offline, or you can just go visit the paper.
so you're talking about terms that exist in ontologies already, not just
Exactly.
me
Discoverable
going through the
terms.
world going, should I call it a dog or a pup?
Right. But
Okay.
we talk a little bit about the case where you don't have, where you can't find one, but really we're not, and how you make that judgment perhaps, but we're not so much about that as we are. You have to choose. How are you going to choose? Yeah. It's definitely a work in progress, and we're happy to have more support if anyone's interested. And I believe.
Yes. I didn't look size.
Yep. Yeah, I think absolutely. Later we can continue the discussing on. I believe people still have questions for Brandon about suite ontology, to June about COR, and from my side, I was want to collect suggestions and feedbacks from you about like what is your interested topics you want to hear about in faculty talks, or do you know any people or research projects or communities who are doing interesting semantic web applications? Please also let me know. But I just want to show you my very last slide. Because I was doing research, and I was also teaching semantic web at a university. And then I think this question was asked the most often, especially for the entry-level students, like what can semantic web technologies do for my research? So, and I think this is very recently, in the recent 2 or 3 years, I was trying to, because I already collected a number of those research projects or just ontologies or knowledge graphs. So in the recent 2 or 3 years, I was trying to say, okay, because many works of nowadays, they're data intensive. So probably I can first use a structured way. Here I just use the so-called data science workflow to basically, it's like a way to lay out the landscape. And then I was trying to match a number of those use cases or research projects or best practices as far as I know, and then to see what is the most important highlight of this work related to semantic application. And then I try to match them to one or a few steps in the data science workflow. For example, schema.org, I think is relevant to data collection or data discovery, data service. And then One Geology Europe, they build some really good applications of the multilingual vocabularies based on SQS. And then on the right, you can see the patronymic exploration at IFP. This is an organization in France. They made use of IBM Watson, trying to use these natural language processing modules and also image processing modules in IBM Watson. But they also face the issue of terminology, heterogeneous terminology like labels. The machine automatically assigned to images. So they also have those interesting semantic web technologies application. And the other tool is GeoBia. I think is geoscience object-based image analysis. This was initiated in, I think it's in the early 2000s. And sometimes when I was talking with my students and then other collaborators, I think, oh, this is actually very closely related to semantic segmentation, which is very popular in the recent 2 or 3 years. I think they are very relevant to each other. And then for sure, for the front end website of either visualization or data service, semantic web can also be used. Like yesterday when Taylor was talking about GCMD, I think on the website of globalchange.gov, especially in the outputs of National Climate Assessment, data.globalchange.gov, GCMD keywords was used a lot on that website as labels or keywords for different parts of the report, including figures, data sets, and publications, and even organizations. So anyway, so if you think you are at an entry level of semantic web and you're still curious, like, what can semantic web do? Or what is the value? What is the purpose? What is the utility of semantic web technologies? Maybe I want to share my personal experience with you. We can use the kind of structured way to think about the value of semantic web. I think this absolutely is kind of simplified way is not 100% correct, but at least I think is a way to organize our source and then to help us have a organized or structured way to evaluate the value and the utility of semantic web. And it's just a short list. Actually, I have more examples, and I have more research projects. Like for sure, I can put a GCMD at here, and also I can put a suite. I can put a COR all in this diagram. But I need a larger slide, I believe. Yeah. Yeah. So this is the last slide I want to show you. I think next we still have a lot of time. If you, oh, the video, sorry. Yeah, I almost forgot about it. So Adam actually shared a video with us about his work on science for schema.org. Just were you already open it? Yeah, I think it should be.
Hi, friends. My name is Adam Shepard. I am the chair of the schema.org cluster here at ESIP, and just wanted to take some time to update you on some recent progress that the cluster's made. So thanks for having us, and let's get started. First off, let's just start with what schema.org is. If you've ever gone to Google and search for a hotel, you might have gotten a search result that looks similar to this on the screen. And what's interesting about these search results is that a lot of the different components about this hotel are pulled out into certain sections. And as you can see here, there's certain buttons that you can click on, like website and directions, certain hotel amenities that are provided, its address and phone number.
And so what's going on here is that this rich result at Google is really driven by a web publishing mechanism that leverages the schema.org vocabulary that's embedded inside the web pages. And so, as I understand it, and schema.org is really about data on a web page that informs harvesters such as search engines and others what your page content is about using schemas agreed upon by both the publishers and the consumers. And the real idea here is that we're making content actionable. And so when we think about that hotel website, all those buttons and things that you can do to interact with that hotel, that property, like check availability, make a phone call, get right to the website, or even get directions, plot it on a map. These make the content on your page actionable to others, so that they can present it in their own formats, as Google's done here. And so what's interesting is that these actions are unique to the various types that you'll find in schema.org. So right now we're thinking of hotel, and so you can do these things like mapping and check availability. But there's a ton of other types in schema.org, which is really interesting because it means that these actions can be specific to the types. And so when we think about research data and think about the types in schema.org, it's really interesting because there's types for research project and describing the components of that, but also data sets. And so clearly data is a big topic and certainly important here at ESIP. And so, what does this mean for science data, that we can make data available on web pages, give some actions to them that others can use, and really just sort of like broaden the discovery of data sets and other scientific information. And so certainly things that we've heard at my repository are like, yeah, we want to download stuff, we want to plot it, we want to analyze it. But the questions about what can be done with this data and information are really endless, and schema.org provides us a mechanism to provide new actions on these content using the vocabulary. And so I just wanted to take a moment to highlight a couple features, so or progresses rather in the field. So schema.org adoption has increased over the years, and to the point where we can now see that the results of these efforts. And so, for example, I'm at the Google dataset search here. And just as an example, I'm searching for ocean time series data, and it's pulling up a number of results. This one is from our repository at Bicodemo, where you can get access to the CSVs and other file formats. And what's interesting here is that the data set is also published at a different website, but Google here, as the harvester of this schema.org, has married the two into one search result, which is interesting. So thinking about those other actions that you'd want to take on a data set, there's other folks out here, not just the major search engines, that are harvesting schema.org content on web pages. So I just wanted to give a shout out to Data One and the work that they're doing. So here they've taken all of the results from Bicodemo, and the ones that had geospatial content in them, they were able to plot it on their search interface, which is really cool. And lastly, I just wanted to share another effort that's ongoing coming out of UNESCO IOC, and this is called Ocean Info Hub. And this is a global effort to sort of democratize access to ocean data. And so they're using the same mechanisms of harvesting repository pages to discover data sets and other things like training manuals, vessels and people and projects, to build a federated interface to discover this stuff for the ocean community. And so I guess that brings me to what is Science on Schema.org. That's the sort of name that the Schema.org cluster at ESIP has sort of branded the product that we work on. And that product really is simply a GitHub repo of guidance documentation. And so you might ask, like, why does the community need guidance documentation? Like schema.org website itself has the necessary descriptions and tools to allow people to publish out schema.org, and that's very true. But what's what was a little bit interesting there is that when you get to the schema.org pages, you're really looking at flat descriptions, and it's really challenging to understand how all things are connected without doing a deep dive. You'll also find that there's limited examples and a number of ways to publish. And so we wanted to figure out as a cluster, like, how do we share these patterns of use so that no one's sort of left behind in the community? And so the purpose of these guidelines, from our perspective, is it provides the geoscience community with some reliable and consistent federation by giving them a specification or how to use or guideline to use schema.org vocabulary in a consistent way across all of our web pages. And so what we do in the guidance is provide more coding examples and some drawings that might help you understand how all the different types within schema.org are connected. And you know, just as an update on what the cluster's been up to, since the ESIP endorsement, we put together a tutorial on like how to sort of go from soup to nuts, like I know nothing about schema.org, right to like publishing out some very advanced concepts. So that was recently published 2 weeks ago in our latest release, version 1.3.2. And so if you go to our GitHub repo, you can see all the descriptions of what's been packaged up in each passive release. And here's the slide on the tutorial. You can find that tutorial at this bit.ly link that walks you through the concepts, how to use it, the techniques that we use, understanding the JSON language and what is entailed there, what you can do with that style of publishing. And then just more recently, even this past month in June here, Bill Manley had requested to provide or suggest working on an extension to describe observing networks. And within this past month, there's been a lot of activity from the group on getting this up and going. Here I'm showing a page of the descriptions and the work that they're doing, mapping science on schema.org out to a polar observing network schema that pre-existed. And so I would encourage y'all folks, if you're interested in schema.org or observing networks or describing your own types, we would love to get your types into the guidance and help. So please get involved. The cluster meets on the fourth Thursday of every month at 2:30 Eastern. You can reach us on Slack or the mailing list, and please, you can just jump right in at GitHub. So go for it. Thank you so much for having us. And I'm sure there's folks in the room that can answer questions for me. Apologies, I can't be there, but look for them. Doug Phils, Matt Jones, John Ralph. We all know you guys. Hopefully some of you are in the room. So, and if I left your name out, forgive me. There's a ton of you guys. So really appreciate all the help in the group, and we look forward to interfacing with you all. Take care.
Just come back. So Adam's, yeah. Yeah, I need just 1 minute. So Adam's work actually also reminds me work we have done in another database, especially the front-end web page metadata annotation. In addition to schema.org, schema.org was initiated by Google, Yahoo, Bing. So this leading search engines. Besides schema.org, there's another one. It's initiated by Facebook. It's called Open Graph Protocol. Very similar to schema.org. They also give you the structure of how to do metadata annotation on your web page. Basically, it's like a text inset into the HTML code of a web page. So basically, Facebook make it really fun. So, for example, if you paste a link to a page annotated with Open Graph Protocol, you can easily see a thumbnail in the Facebook timeline. I think that's how it works, or at least one of the ways how it works. Because in the method allocation, you can specify, for example, which thumbnail or which image I want to show when people share the page link in Facebook timeline. So that's just another interesting resource I want to mention. Next, I think we still have about 25 minutes. So yeah, feel Open Graph Protocol. Yeah, it's called short name is OGP. OGP, I think. Yeah. Yes. It's just another possibility. Okay, yeah. Yeah, we're open for discussing comments, questions, answers now. Yeah.
John Ralph, NOAA NCEI. Yeah, I wanted to actually say something about, in response to what Adam was talking about with scienceonschema.org. The NCEI microplastics team wanted to share their data and federate with Ocean Info Hub. And so Pierre-Luigi Buttigieg and team did some evaluation of the NCEI schema.org and basically told me, you got some problems there, buddy. So I was able to look at the scienceonschema.org documentation and address a number of their concerns. And so we then turned around and had Pierre-Luigi look at it again, and they were able to do the integration. So that documentation is very helpful for not just developing initial schema.org implementations, but also for improving it over time, because of course the so-so guidance is an evolving thing.
Yeah, and also actually in our work, because I was leading a project funded by NSF is to make the MinDat database is a database in the field of minology for minnow species and the distributions. We also have a lot of front-end web pages. Currently, we already deployed Open Graph Protocol. And next step, we will also want to use schema.org because we also want our data resources to show up on the data search engine of Google and also probably DataOne. And I know some time ago, Earthcube also has Decade. It's also a kind of catalog for the open data resources. So I think very similar to the work you mentioned. Anyone else? Okay, good. Best.
I'm really a fan of schema.org. I'm looking at Valerie because I wish we could use it at NASA more. I'm thinking at the variable level that we should start publishing those schemas to, but I have a question, a more general question, because I guess, I don't know, in my old age, I'm getting lazy and also I'm just not as in touch as I used to be, but you talked about information models the other day. And then we're talking, and we're talking about vocabulary. And I'm wondering sort of, how we tease, like, is it better to just tease these things apart, right? That we have information models at NASA that are really quite well thought out, and what we need are vocabulary words to fill those in, and should we think of these separately, right? Like, should we just not, people say, well, use this ontology or that ontology, and I think we get confused about it by saying, in what way should we use the ontology, right? And I think we care less about the structure of the ontology than we do about the terms that it has and whether or not those terms, I mean, sometimes the structure informs the definition, but not always in a helpful way. And, which is why I'm like, just give me the bag of words, right? So that I know what values to plug in my schemas. And so that's just one observation. I mean, I don't know if you guys are, if you have any comments about that, I'm curious to know what your position on that is. Like, And does schema.org have a bag of words that people choose from for the values that get plugged in for to the metadata elements that they include? Okay, so if I were to use it, like I could find,
Sometimes,
okay.
some attributes. Good, yeah.
John Ralph again. Yeah, one of the things that the Ocean Info Hub folks said was that there is value in referencing the specific vocabulary or ontology that you're using. So yes, you can put ad hoc terms in, and yes, we do put ad hoc terms in. But if there is a well-defined community vocabulary or ontology, you should probably reference that.
Yeah.
So
Wholeheartedly agree with that. I'm just asking if it, can I pick and choose from whatever one works, right? Do I have to always go, it's always gonna be from Enro or from Swede or something? Can we go all over the place and what's the downside?
I think yes, the answer is yes. You can do whatever you like. And reference those and use the terms that make sense for the domain you're trying to describe and pick and choose. But if there are more commonly used ones, it's better to use those because that's likely to link up better with other.
Yeah.
I'd like to answer this in the context of your first question, and I may cover some of the same ground you would cover. This answer is influenced by the fact that I was a leader manager of the CEDAR project, which is all about creating semantic forms that are essentially defining information models, right? It's what's the protocol you're going to use to fill out metadata for your community. So you are defining standards with the form, and then you're filling out the values with the semantic choices that you make. And you have the choice of when you're building that model of that form of saying, how many different vocabularies or branches or whatever you're going to support. When you talk about the bag of terms concept, it makes me cringe a little bit because a bag of terms is a useless organizational system. A hierarchy is a very useful organizational system, even though you have a little bit of branching issues that come up with it. So it's a very easy tool for me to control the terms and standardize the terms that I get in the responses from my community, which goes a long, long way toward simplifying the interoperability of all the people who are using that form. And so while you can choose to leave it wide open or say you can use any term from any of these 10 ontologies, you are encouraging divergence at that point, right?
Yes, I'm not encouraging that. Sorry, I didn't mean to be misleading about that. But we as does or something, my bag of terms is like, oh, I'm gonna put together this bag of terms by pulling a bunch of different colleges. Go ahead.
Okay.
I didn't mean me personally or
Making my
anybody
eyes
personally.
bug a little. So in the realm of what could possibly go wrong.
Right.
So I don't think that there's terribly much at risk if we're talking about, hey, we have a gaping hole here. So let's use those keywords from that ontology over there. That exists, it's fleshed out over there. That's great. Where you run into problems is where you have areas of ambiguity and overlap and duplicativeness. And then you cannot do anything programmatic anymore. From an application standpoint, you need to make sure you're all talking about the same thing, or your searches aren't going to work. Your subset of your tools aren't going to work. Like you need to have that disambiguity. And you can do that across different ontologies, but then you run into the whole harmonization non-trivial problem of if we can know for sure that this thing here is the same thing as that thing there, but not the same thing as that thing over there, then you, yeah, sure, get your grab bags.
Clarify
Yeah.
what I meant here was, can we NASA get ourselves a big bag and say, we need some vocabulary for our, to supply values in these schemas that we have, and we don't have it. And so I like this word and I like this word, and I'm going to put them all in my bag, and then we'll organize them ourselves once and I did not mean that any metadata editor or curator at NASA should just go off and find whatever term they want. What I meant was, can we pick and choose and pull together a vocabulary from disparate ontologies, and what problems are we going to run into if we do that?
Can I make a comment first? Sorry. So I think one of the purpose of the cluster science on schema.org is to build those kind of best practice, or even generate some guidelines to build those domain specific vocabularies people can use together with schema.org to allocate those open data resources on different subjects. And then for exactly those terminology in those disciplines, I think traditionally we usually apply a kind of top-down approach, trying to find are there any community level standards or terminologies. And recently, I think is initiated by a few people, including Pascal Hissler. He said, why don't we also leverage some kind of bottom-up approach? And he was saying, probably we can use large language models to together with the guidelines we already have on science on schema.org, and then using the advantage of large language model to get as many as this terminology as possible. But for sure, I think there's still some work there to like verify the quality of the result to see whether it's usable for the application. If you want to use it for open data portal or some other works. So, yeah, just some comments.
Well, and I think technology now allows us to have those linkages between other living entities in ways that we didn't have before. We used to have to say, oh, wow, I really like that. I'm going to suck it in and take a fork and put it in my thing. And then they're going to divergently evolve. And then many years later, like we did with USGS and NOAA before the pandemic, we'll come together and say, hey, can we get your GCMD forks? We all have oceanic terms now and they're different. We need, let's iron those out. And it was a slow and painful, but forward moving effort that the pandemic completely derailed. Unfortunately, we got through atmospheres. I think we got through oceans. We were going to take on the next one. But I think now there are better technologies and capabilities to have those links to other branches in other ontologies rather than recreating them instead. The last time we did this actually was when we introduced machine learning to GCMD, where there wasn't anything, and we looked and looked, but we ended up making our own instead. Please don't make your own. Tell us what to fix.
Session earlier this week, I don't even know what session it was showing a slide where they were showing a slide where they had an entity, right? The thing, the object in the world, and then, had then had like a bunch of mappings of terms or something onto that thing. And I love that approach. I mean, that's what I want us to try to do, but then I really get into despair. I mean, I don't know if I just overthink everything, but Ruth, if you're still there, I have a question for you. Is it sea ice or is it ice in the sea? Right? Like is sea ice a thing, or is it just ice that happens to be in the sea? What's the relationship between sea ice and, other ice? And so when
Where it was formed. And yes, if you actually went to ENVO, you would know that, because that's the definition. In ENVO, the human readable definition and the actual set of axioms are supposed to be parallel. They are not always so, but the human text readable definition should show up as axioms. But ENVO, as everything else, is like 1 million years old. So it's only things that have been recently modified where that is true. But I put an example of what metadata can look like. I put a data set from NASA's Gene Lab repository, a link in the chat. And I was doing it just to show exactly the kind of thing you can do, because if you pick up this data set, and it was just the first one on the list when I did a search, and you look at it, it's got all this red stuff or blue stuff on my screen. And if you actually mouse over it, you'll realize that that blue thing is an ontology term. And then if you mouse over a bunch of them, you'll find out that they come from a whole bunch of ontologies from a whole bunch of different countries. And that these are just standard terms now that have real definitions and such everywhere. And so the point is that if you can get to the point where you can agree that these 40 ontologies cover the range of things that we're doing with our search and discovery thing, then you can mix and match the ontology terms. And any one of those fields, like on the factors that they had there, you could get factors from different kinds of ontologies, because in the bio world, they have a lot of very small ontologies that cover sort of individual diseases or protein types or, all sorts of things. And the repository allows you to, okay, so for this term, these 4 ontology things, are probably where you're going to want to see them from. So,
Yeah, Ruth, thank you. But that was a rhetorical question. I mean, I'm a philosopher, so my point was that, yeah, okay, you think that it's sea ice, or I don't even know. I'm not sure what your answer was, but it depends, right? It
that's
depends.
exactly right. That's exactly right. And so if you have a different kind of thing, you actually don't care about the factor that sea ice is, ice that formed at sea.
Right, exactly. Depends on what you're doing, right? If you're interested in the sea, then maybe you only care about sea ice. But if you're interested in ice writ large, then you don't really care that it's sea ice, and you don't want to be restricted, to this.
And exactly those kinds of issues are things you can work out in ontologies. For example, it turns out that many of the different types of what you would call sea ice actually can occur in fresh water as well. So that's fine. You just have to know that, and that's why the semantic harmonization group worked on that paper about how to do semantic harmonization for so long, 3 years, I think.
John Ralph again. I was thinking about what you were saying about, taking a bag of terms and making a new ontology out of it. And at NCEI, we found that is really expensive over time, because you basically agree to maintain that forever. And of course, exactly. So at NCEI, we did the same thing, and boy, do we feel stupid. So we need to figure out how can we change our documentation to use community-supported vocabularies that have already defined the things that we're interested in. And so I was really interested to see Ruth's example where that repository is allowing terms from tons and tons of different ontologies, because those ontologies define the terms exactly the way they need them, even though there's a lot of ontologies, which is kind of, this seems to be flying in the face of what you were saying about making the job hard of doing that harmonization.
Well, I don't think it is, because I think the other thing people aren't quite getting here is that there's a difference between a domain ontology, which means that people in the domain have gotten together and agreed that these are the terms we're going to use for this specific purpose. and an application level ontology, which is all about, oh, I have an application I need to build. And maybe I need to use these 4 domain ontologies, this one for this kind of thing, that one for that other kind of thing, etc. And domain ontologies are the things that domain experts with ontology type people need to maintain forever. Application ontologies could come and go with the application. You know, technology changes. Well, then maybe you don't need that application ontology again. The issue is the domain ones. And yes, there are many ways to come at a particular problem. But if that problem is something that these 40 communities need, then maybe those 40 communities need to get together and create the ontology for that thing. And that may be good for a very long time. People have been working on, for example, cryospheric terms and their definitions now for what, 40, 50 years or more. And they still do that every couple of years, but the changes have been getting smaller and smaller and smaller over time. And so the definitions have been getting tighter and tighter and tighter over time. And that's a good thing. And at some point, you know, things are not going to change much, if ever. I mean, maybe there won't be any sea ice ever anymore, but you know.
Okay, sorry, Ruth, I am not sure maybe I don't understand what you're getting at with application ontologies versus domain ontologies. I mean, we have applications that need to use metadata that, you know, that are may or may not go away, but we don't want them to have their own ontologies. We want, I mean, I guess I'm not quite sure I
The
understand.
person who builds the application makes that choice. Who someone building an application chooses, or a template, the information model chooses what their use case is and what the appropriate ontology, part of ontology, mini ontologies, terms, whatever is.
Not if they work for NASA. Still, sorry, I don't.
Well, so yes, if they
You
work
want to
for
make up
NASA.
your own ontology, but all the data is out there labeled with other stuff. You're gonna have a problem.
That's a
an
deeper
interoperable-
conversation that we're not going to solve here. We could if we sat down for three days, but we're not going to solve it here. But the
I mean, I'm just misunderstanding.
it's a little bit, I wanted to respond to your comment earlier, John, that I heard several times from NOAA people mostly, but I think it's a fair generalization, fair general approach, that we don't want to maintain these ontologies. We don't want to get in the business of maintaining ontologies. We're just going to use other people's ontologies. And a little bit the implication of that was, so we don't really need to worry about being responsible for helping things like core to be around, because we're just going to get them from wherever they are. And I wanted to contrast that to what I hope can become NOAA's and other agencies' perspective, which is we are a leader in the field. We consider it our duty as a leader to be responsible to help maintain principled ontologies like GCMD, like others, and to help make sure those ontologies are published in a way that other people can access them. Because philosophically, if everybody says, we're not investing anything in building ontologies, we're letting somebody else do it, there's nobody left to build ontologies because nobody is funding it. So there's a balance here, I guess, is all I'm hoping we can arrive at. And I'll stop there because we're starting to get close to time. And I know Brandon has, but just remind everybody, please sign up to the website if you haven't, to say you were here. Thanks.
Yeah, okay. So thanks again, everyone, for your time in this session and this active discussions and comments. I made some notes, so absolutely I will make some action items for the future activities within this committee. And also, again, tomorrow morning, Brandon will run another semantic session. So if you want to continue the discussion, just come by and yeah, we can absolutely have more discussing. Okay. Hope you enjoy the rest of the meeting. See you tomorrow.